So the next chapter in your book is chapter 5-3, polynomial functions. And so now we're going to be looking at, ways of just, even before you graph it, to try to understand what kind of a function you have just by looking at the equation or the expression they give you. So, for example, let's look at the type of polynomial that you're going to have. First of all, if you just have a constant, like a number, right? Well, a number is just, there's no x value here or anything like that. So then the degree would be 0, and the leading coefficient is just that constant number. Then you could have a linear function. Remember, it's x to the first power, so something like 4x minus 9 equal to y as an example, right? This is just an expression here. But if you notice, what is the degree? Well, what's the highest number of the power of the variable? So x to the first power, this doesn't have, it's x to the 0 power, so it's not larger. So x to the first power, that's where you would get, that's the highest degree, so the degree is 1. And who's leading coefficient? That's the number in front of the highest power variable, so in this case it would be 4. Now, how do you know if you have a quadratic function? Remember, quadratic functions are squared, right? X squared, cuadrado. So the leading coefficient is your 5. And what's the highest degree? This is a degree 1, degree x to the 0 power, so 0. So the highest degree is 2. And so if you notice a little pattern, linear is to the first degree, because remember we said that it has to be x to the first power. If it's quadratic, it's x to the second power. And so now cubic, something that's cubed, is to the third power. So if it is cubic, then you have x to the third power, and of course that's the highest degree. The leading coefficient is 8, and so of course this one is degree 2, degree 1, so the term with the highest degree is this one, so that's the degree that it takes. And so I think you all kind of developed a general, kind of format or the pattern. So if you notice, all you need to do is to figure out what kind of degree and the leading coefficient of expressions is. You just look at the power, so x to the 4th, x to the 5th. If that's the highest power that you see, then that's the degree, so it takes on that degree. Of course, the leading coefficient is always the number in front of the variable highest power. So we're going to be looking at what is a polynomial function. So here are a few more notes with some basic vocabulary that you need to learn. So polynomial functions is a continuous. So in other words, there's no gaps, right? It's just flowing a smooth either curve or something that you have, or a line, etc. So a continuous function that can be described by the polynomial equation with one variable. So if you notice here, the equation described in terms of x. So and this is what? Well, it's to the third power. So it's a function that is cubic. And it is polynomial because it has 1, 2, 3 terms. It would be like a trinomial, right? Because it's got 3 pieces, so it is a polynomial. What's a power function? Well, a power function is some coefficient times x to the something power, right? So b is a power where b is not 0 and a is not 0 either. And so there are some non-zero real numbers. Now, we're going to see the words and behavior. And this just tells you the behavior of a graph, such as like f of x, as x approaches positive infinity or negative infinity. So how does the graph look at the end? When I finish graphing this thing, if it's a curve, a line, something, what is it doing towards the end? And of that as well. So that is what you'll be learning in section 5-3 for polynomial. Let's look at your packet. So in your packet for 5-3 polynomial function examples, the first thing you see is some vocabulary words that we went over quite a few of those already. So make sure you familiarize yourselves with those and have the all of these. Then it starts off with looking at trying to find what are the leading coefficients. So we look at this example here. The highest degree is to the third power, so I see that's a cubic function, and the leading coefficient is 7. So the degree is 3. The leading coefficient is the number there that's in front, which is the 7. I continue looking. You'll have some more examples for you to try. And then in some cases, it's going to ask you to evaluate the function. So whatever it tells that, like in this case, b of m is equal to this stuff. So then you're going to have to substitute that. And it shows you the steps here. See this took the place of the x, right? So what are you going to be doing? You're going to be replacing that instead of the letter m. So the example is right there and stuff. So just, kind of follow along as they give you instructions. And so it's asking you to evaluate different functions by replacing certain things that they're telling you that it's equal to. So if they tell you the function of b is equal to this, then of course you're going to be substituting that in as well, just like they give you this example right here. So, just go through the steps, and that way you can see how this functions with new variables and so on. All right, so then let's go ahead and look at this. This is some information, and you have your packet, so it should be a little clearer on slide 25. It shows you the different type of equations, what they look like. You've seen parabolas already, of course, facing upward, facing downward, when the A is positive, A is negative, and so on and so forth. So you're going to be looking at some more of those examples as well. So now we look at the C guide part. Here you have some examples where they tell you f of -5. So anytime they substitute x with some number, you do the same. You plug in a -5 everywhere you see an x, and then there you have it. So that's something that you can done that can be done quickly. If they tell you what is g of a squared minus 1, they're not only asking you to replace just one number for x, they're asking you to replace a variable in a number. So everywhere you would see that letter x, you replace it with the g of whatever they give you. In this case, it's a squared minus 1. And so you can do those as well. All right, do a couple of exercises together. So it says state the degree. So again, I look at the exponent that has the highest number. In this case, it would be the 4. So in this particular case, I'd say degree of 4. So it would be like a quartic, so degree is 4. The leading coefficient, I'll call it LC for leading coefficient, is the number that leads right there with the highest degree, so that would be. And if it is not a polynomial in one variable, explain why. Well, x, I think I'm good. I think that explanation when you get to that particular problem, so just kind of look out for that. The next, now it's asking you to find f of 2 and f of -5 for each of these situations. Let's do one. So f of 2 would be replacing that x with a 2. So I would end up with 2 squared minus 4, 2 squared minus 9. So you have 4 minus 9, which is actually equal to -5. So that's one answer. And now I need to replace it with -5 in here. So I replace all the x's by -5. Now this is where you have to be careful. If I'm replacing the x with a -5, that x is squared, so I have to square the negative part as well. And so -5 squared is -5 times -5 is positive. And you have here 25 minus 9, which should give you 16, if I'm not mistaken. Therefore, just be a little bit careful with the options that have the substitution in there, so you may make the right substitution and the right order of operations. So now we continue with the more questions here. And so it's asking you to see what the end behavior is. And so it's basically, if you look at the example here, you see what is happening over here. And if you notice, like this particular graph just kind of continues and continues on to positive infinity. So then you can see what is happening. Now, the only thing they add here is to look at the degree. If the degree is odd and the degree and the leading coefficient is positive, then the function approaches negative infinity as x approaches negative infinity, or as if the function approaches positive infinity as x approaches positive infinity. So there's just some things to look at, read the information so you can describe what's happening at the end in the end behavior of these functions, because some of you'll notice they're going up, some are going down, and so on and so forth. And then it's asking for the real zeros. Remember, you've done that. The zeros are the x-intercepts, so that's what it's looking for, like these spots right here. Then you're going to be, same thing, setting the degree, leading coefficient, etc. Now you're going to be finding a replacement for some of these. So let's go ahead and just have a look at, I've already done examples like that. But if you notice here, it's saying, okay, so what is P of 8a? All right, so what they've done is every x that you see, they've replaced it with 8a. So I'm going to do the same. So P of 8a is equal to 3, and then I put the 8a in the spot of any x that I see. And, well, it's just 1 in this case, so there it is. And so I continue the process. I have 3 times. Remember, whenever you have something to a power, you got to distribute this to both of these. So 8 squared, 8 times 8 is 64, a squared, and then minus 4. But that still has to be multiplied by the number 3. So 3 times 64, I get 12, carry the 1, 192 a squared minus 4. And I think I'm done because if this had a squared, then I could subtract them from each other, but it doesn't. It's just one is a squared, the other one is just a number. So I pretty much have to stop at that point. And so basically you have to continue with that, looking at these for each graph. Let's look at the end behavior and so on. So let's look at question number 17. So here we have to look at 3 things. So letter A says, describe the end behavior. Okay, so let's see what's happening over here. So if you notice, the function is going upward. So we say as the function is approaching positive infinity. Let me make that clearer. Sorry. As it is approaching positive infinity, what is x doing? Well, look at what x, it's coming this way, right? And so the x, it would be at negative infinity because it's going -4, -5. So it's coming that way. So the x is approaching negative infinity. So let's look at the end behavior here. So as the function, notice how it's still growing to positive infinity, right? Because it's just continuing to go up. Then what is the x doing? The x, if you notice, it's coming this way, this way, this way, 4, 5, 6, that, so this side is positive infinity. The x is approaching positive infinity. So we that'll be the answer for part A. Now let's look at part B. B says to determine whether it's an odd or an even function. All right, so it looks like the end behavior is they're both going up. So if they're both going up, then this would be an even function. So if you notice, this would be an even function too. This one is going down, one is going up, then you would call this an odd degree function. Okay, and then state the number of real zeros. Remember, the zeros are the x-intercepts where it crosses, and so therefore it has 1 here, another 1 here. So then you have 2, oh, sorry, let me activate the pen, 2 zeros. And now we've answered all the questions. We could also look at this one here. It's 1 0. And this particular one has 1, 2, 3, 4, 5 zeros whenever you're doing those questions. One last thing is I said it, but I didn't write it. So that would be positive infinity like that.